Okay, good morning students. So in this session we will discuss about the DFT 8-point DFT computation. So last session we have discussed about the 4-point DFT computation and IDFT computation we have done by using matrix method, also direct computation also. So in this session we will discuss about the one problem for 8-point 8-point DFT computation. 8-point DFT computation using direct method. Computation using direct method. Okay. So here the DFT, one of the DFT important properties, so many properties of DFT, out of which the important properties we will discuss: the periodicity property and symmetry property. Okay. So these two properties I'll explain how it is very useful to compute the 8-point DFT, because the 12 factor plays a vital role in because the 12 factor. Okay, what is the 12 factor? W is equal to e power minus j 2 pi by n. So this is the 12 factor. So the symmetry property, by expressing the periodicity property and the symmetry property, we will compute the symmetry property. I will explain now. If a x of n, if it is a real, for example, if x of n is a real, for example, symmetry property, the x of n minus k, x of n minus k, which is equal to the complex conjugate of k, x of k, n minus k. So this is very useful, the symmetry property. So this, what is this? This is a complex conjugate of x of k, complex conjugate of x of k. So in which you can find the real part of x of k, which is equal to the real part of x of n minus k. Okay. The imaginary part of x of k is equal to minus imaginary part of x of n minus k. Okay, the phase, you can see the phase x of k is equal to minus x of n minus k. So remember that the symmetry property, which will be useful for when you compute a higher endpoint computation. So the 12 factors. By exploiting the periodicity property and the symmetry property, we can write W. So by exploiting periodicity and symmetry property, the W power k plus n by 2, which is equal to minus Wn, the complex conjugate of this term. For example, so W power, okay, W power k plus, For example, n is equal to 4, by 2, 2. The two properties, so k plus 2, if k equal to 0, so this is w per n k plus 2, which is equal to w n k. For example, n is equal to 4, k equal to 0, for example k equal to 0, so w n k, which is equal to w n power 0. Okay, w if k equal to 0, so this is w two. Similarly, you can write 1 w n 3 is equal to minus w per 1, w per 4 is equal to minus w per 2. So k equal to 0, k equal to 1, k equal to 2, so w per 2. Similarly here, k equal to 3 means k is equal to 2. So w per 5 is equal to k equal to 3, so which is equal to minus w power 3. K equal to 4, so w power 6, so w power 6 is equal to okay minus w power 3, w power 7 is equal to minus w power 5. So w power 8 is equal to w power 6. So because of this periodicity symmetry property, we can write w power k plus n by 2, which is equal to complex conjugate of that is a complex conjugate of w n. For example, for the given endpoint, okay, one example will take DFT. Find DFT for the sequence 1, 0, 2, 4, 5. So in this, what is x of 0? So what is x of 0? 1 plus 0 plus 2 plus 4 plus 2. This is 4.5. 1, 0, 2, 4.5. So 4.5. So 6, 7.5. Okay, the angle is 0, you can see. Similarly, x of 1, if you calculate by direct computation, you will get 1 minus 3.5 j. So you find the angle and the 90 phase. So you can write x of 3 is equal to x of n minus k. So 4 minus 1, which is equal to complex conjugate of x1 of. Okay, so the formula, you know, x of k is equal to the summation of n equal to 0 to n minus 1 x of n into z complex conjugate of k. Okay, complex conjugate of k. So x3 x of 3 is equal to, now you can say 4 minus x1 complex conjugate of x1 of k. So 1 plus 3.5j. So like this you can write. So x of n minus k. So what is that? This one you remember, the if it is a real, so the real part as such you can write, the imaginary part minus of imaginary, so that is your x of n minus k is equal to complex conjugate of x of k, complex conjugate of x of k. Okay, so similarly you can find, I'll give an example for 8-point DFT computation using symmetry property. You can find out directly. Find 8-point DFT. The 8-point DFT sequence is given. So x of n is equal to, this one problem, exercise problem. X of n is equal to, for example, 1 comma 1 comma 0 comma 0 2 0 comma 0 6 0 comma 0. By using symmetry property, okay, by using symmetry property you can determine the x of k. What is x of k? The summation of n equal to 0 to n minus 1 x of n into w power nk. Okay. So w, what is w? E power minus j 2 pi by n into k, nk, 2 pi by n into nk. So x of 0 will be, and the first term will be, so 0 anything but 0 1, so x of 0 plus x of 1 plus up to 8 minus 1 x of 7. This is x of, this is x of 0, this is x of 1, so other terms are 0, x of 2, x of 3, x of 4, x of 5, x of 6, x of 7. So n is equal to 8. So 8 minus 1 will be 7, 0 to 7. This will be 7, 0 to 7. So x of 0 plus x of 1 up to x of 7. So only x of 0 and x of 1 is available, 1 plus 1, remaining will be 0. So we will get 2. Similarly, you calculate for other terms, x of 1, next term x of 1. So this is e power minus j 2 pi by n. Okay, e power minus j 2 pi by n is 8 point. Okay, so x of 1, so what is that? N equal to 0 to 7, x of n into e power minus j 2 pi by n into nk. K is 1, this is k. So k is 1, so x of n into e power minus j 2 pi by n is 8 into k is 1 into n. So we will get 1 by 2, 4. Summation of n equal to 0 to 7. Next, the sum n equal to 0 to 7, x of n into e power minus j pi by 4 into n, minus j pi by 4 into n. So n is equal to x of 0, so n equal to 0 1 plus x of 1 into e power minus j pi by 4, so which is equal to 1 plus, so this is 1, so you can write cos pi by 4 minus j sin pi by 4, for example. So we will get 1 plus, as a cos pi by 4 1 by root 2 minus j 1 by root 2. So you can write 1 plus 1 by root 2 minus j 1 by root 2. So 1 plus, so how you can write 1 plus this one. So you can write 1.707 these two terms, then 1 plus j root by root 2 minus 1 by root 2 minus j 1 by root 2. So you will get 1.707 minus j 0.707. So x of 2, similarly x of 2 will be, so you will get x of 2 summation of n equal to 0 to n minus 1 7 x of n into e power minus j minus, so e power minus j 2 pi by e power minus j 2 pi by 8, n is 8 no, into nk, k is equal to 2, nk 2 into n. So 1 4, 1 4s are 4, 2 4s are 8. You can simplify here, n equal to 0 to 7 x of n into e power minus j pi by 2 into n. So only two terms no, so first term will be anything power 0 1, so x of 0 into 1 plus x of 1 into e power minus j pi by 2 into n. So x of, so 1 plus, this term is 1 plus cos pi by 2, this term you can write cos pi by 2 minus j sin pi by 2, 1 by root 2, that is a 0. So 1 plus e power minus j pi by 1 minus j, you will get minus j, 1 minus j. So now x of 3, next x of 3 you can get summation of n equal to 0 to n minus 1 x of n into e power minus j 2 pi by n, this is 8 into n into k, k is 3, so 4, 3 pi by 4. So you will get x of 0, this 1, x of 0 into n to the power 0 1, so this 1 plus e power minus j pi by 4, j pi by 4, j 3 pi by 4, this is 3 pi by 4. So you can write, clearly I can write e power minus j, this is 3 pi by 4, this 1 is equal to 1 because only first two terms are present. Easy to understand the symmetric property. So in that case you will get point, so if you calculate, just use the calculator, you will get 0.292 minus j 0.707, 0.7, use calculator, cross check, you will get the value. Then x of 4 is equal to summation of n equal to 0 to n minus 1 x of n into e power minus j 2 pi by n is 8 into n into k is 4, 1 4s are 4, 2 4s are 8, 1, so j pi, summation of n equal to 0 to 7 x of n into e power minus j pi, j n pi into j n pi, e power minus j n pi. Okay, so if it is 0, x of 0 into x of 0 plus x of 1 into e power minus j pi n is equal to 1. So x of 0 plus cos pi minus j sin pi. So in that case will be 1 minus 1, which is equal to 0. Okay, x of 4 is 0. Now x of 5. See, first 4 sequence if you find, by using symmetry property, you can compute the other sequences by using symmetry property. What is symmetry property? Says x of k is equal to, that is x of complex conjugate of n minus k. So x of 5, you can write x of 5, which is equal to complex conjugate of n minus 5. So complex conjugate of 8 minus 5, so which is equal to the complex conjugate of 3. So x of 5 is equal to complex conjugate of 3. So what is what is x of 3? X of 3 is equal to point. So this is x of 3. X of 3. What is x of complex conjugate of 3? So the real part as such you have to write. The imaginary part will be minus of plus j 0.707. Okay. Similarly, so this is the answer, 0.292 is equal to 0.292 plus j 0.707. Similarly, if you want to compute x of 6, you can write the complex conjugate of n minus 6, n minus k. So complex conjugate of 8 minus 6, which is equal to complex conjugate of 2. So what is a 2 here? Complex conjugate of 2. X of 2 is, what is x of 2? This is x of 2. This is x of 2. This is x of 2. So what is complex conjugate of x of 2? Which is equal to 1 plus j. So now x of 6 is equal to, complex conjugate of 2 will be 1 plus j. Similarly, x of 7 is equal to the complex conjugate of n minus 7, which is equal to complex conjugate of 8 minus 7, which is equal to complex conjugate of 1. So what is complex conjugate of 1? Complex conjugate of 1. So this is x of 1. So this is x of 1 value. See, this is x of 1. This is x of 1 value. This is x of 1 value. Now what is complex conjugate of x of 1? Real part as such 1.707 and the imaginary minus also plus j 0.707. So you can write x of 7 is equal to, so it is x of 7, which is equal to 1.707 plus j 0.707. So now you can write the sequence x of k. You can write the sequence x of 0, x of k 2 comma 1.707 minus j 0.707, second point 1 minus j, then 0.292 minus j 0.707 comma 0 comma this symmetry property. So 0.292 plus you see here, no, by using symmetry property. This is x of 0, this is x of 1, x of 2, x of 3, this is x of 4, this is x of 3, this is x of 2, so 0.292, this is x of 5, so 0.292 plus j 0.707 and 1 plus j and 1.707 plus j 0.707. So x of 5, this is x of 6, this is x of 7. Okay. So this is a direct computation of, so DFT, direct computation, which will take more number of multiplications and addition. So how you can use the periodicity property and the symmetry property to find out the endpoint DFT. Okay. So with this we can conclude the DFT computation. So next session we will discuss. So since it requires a large number of computations for the direct computation of DFT, we can go for the fast Fourier transform FFT computation. So in the FFT computation, the trill factor plays a vital role by using a periodicity and a symmetry property, and with the basic 2-point computation butterfly structure for endpoint, 4-point and n 8-point decimation time, decimation frequency, FFT and algorithm and all we can compute. So before the endpoint FFT algorithm, so what is the DFT, what is the direct computation of DFT, what are the computations required, then how the symmetry periodicity property of trill factor plays a vital role. So all the basic fundamentals you should know. For this only the session clearly explained the fundamentals. Hope you understood what is DFT, how to compute the DFT by using symmetry property. Okay, thank you.